Okay, thank you for inviting me here and coming to hear me speak. I haven't got any slides. I think slides are the death of presentations. Something that doesn't invite participation from the audience at all, does it, a set of slides? So a while ago I sort of ditched slides and we'll just see how it goes without them. I think I've got 90 minutes. Is that right? That seems a long time. I'm not sure I've got 90 minutes. If we're okay, well, I've got what I've got here, and when that runs out, if we've still got some time left, we can decide what to do then. Okay? I'll just briefly introduce myself a little bit. My name is Jon Jagger. Surname might be familiar to some of you. No relation to Mick Jagger, thankfully, I think. And I'm, how old am I? I think I'm 47 at the moment. Married with 3 kids, as one of each, as someone once said. And my background is sort of the curly bracket languages. But 13 years ago, I went independent. And I've been doing that ever since, traveling the world, trying to help companies out. And when I did that 13 years ago, I very, very quickly realized something. Because as I imagine lots of you are now, I was 13 years ago. I was heavily technical, deeply technical person. Didn't really care about management, didn't care about people issues, to sort of use that phrase. I just cared about coding. And I would get really, really into the details of all the nuances of the language I was using. So for a while I was in the UK panel for standardizing C++, and then I was in the panel for UK panel for standardizing C#, etc., etc. And when I went on my own, what I realized very quickly was how well I know something is totally irrelevant, because all I'm trying to do is help my customer. Okay, so my focus switched completely, and I don't have that strong sense of thinking about the technical side of things, but I do like to keep my hand in. I do like to keep coding, because otherwise I think it very quickly shows, frankly. So that's a little bit about me. This is an XP conference, isn't it? XP. And one of the talks I listened to earlier was talking quite specifically about XP and talked a lot about pair programming. So I'd like to give you what I call the XP test. Imagine I was an alien from a completely different world, and I came down in and you said to me, we're doing XP. I'd say, really? What's XP? What is this thing XP you keep talking about, right? What would you say to me? What would be the first things that popped into your head if you were trying to explain to me what XP was? Anyone? Iteration? Okay. Anything else? Sorry, I missed that one. Quick programming, anything else? Better code? Pair programming? Pair programming is one of the specific practices of XP. Pair programming. I was thinking about the specific practices or anything else that you might think of. TDD, love it. A couple more maybe? Yeah, I think we've already mentioned that one. Automated tests. You're looking on the internet maybe? Yeah. There's a few others. Again, thinking about the talk from earlier this morning, another one was collective code ownership. We could go on. But the point I want to get across to you is I do this test lots and lots and lots, pretty much most places I visit in the world. And when I just open it out like that and say, tell me about XP, what I never get back, except one place I went to and they did talk about this, what I never get back are the 4 underlying values that XP is supposed to be based on. Right? So does anyone know any of the 4 underlying values that XP is supposed to be based on? Actually, to be fair, there were 4 underlying values in XP Edition 1, but in XP Edition 2, Kent added a 5th one, if you read it very carefully. So I'll accept any of the 5. But does anyone know any of those underlying values? Feedback. That is definitely one of the core values he says XP is built on. Nope. Nope. Excellent. Who's surprised by that? Courage is one of the 4 underlying values of XP. Yeah? You know the other 2 more to go? Simplicity is definitely one of them. And I love his definition of simplicity. Do you remember what it was? The art of maximizing the amount of work that is not done. Trust was the 5th one he added in XP2. The last one in XP1, communication. Now I mention this because, like I said, I was deeply technical, and if you'd asked me this 13 years ago, I wouldn't have had a clue what these were, but I'd have known all about this, particularly the ones involving programming. And a friend of mine sort of made me aware of that, and he said, reread the book. Knowing these are the 4 underlying values and thinking about that as you reread the book, it makes such a difference, I'll tell you. Such a difference. I really strongly encourage you to think about these practices in the context of these values. For me, it made a big, big difference. Yeah. Anyway, just a little thought there. I've noticed in all the talks so far, someone's at the front talking with PowerPoint presentation and no questions from the audience. I don't like that. I think asking for questions at the end of the talk doesn't really work. So if you've got a question, I want you to ask that question at any time. Okay, I think it works much better. I'm relying on you to do that. Okay. So, this is a tool I built a couple of years ago. It's been up on the web for a while now. I'm not going to go particularly into the detail about this for 2 reasons. Number one, that isn't what I said I'd talk about. I said I'd do a bit of live coding, which is what I'm going to do. And the other reason is I understand that at this conference last year, there was a Norwegian gentleman called Johannes Brodvall. I don't know if anyone went to that. A couple of people said they did. And I'm told he actually used CyberDojo. Don't know whether that's true or not, but it's got some exposure here already. So, as I say, I'm going to use it, but not really talk about it. That's the website if you want to use it yourself, cyber-dojo.com. But the internet connection here seems a little bit flaky, so I'm going to use a local server on my local machine. It's exactly the same. Okay. So, let's do some coding. Now, the first thing I'm going to mention is that I said in the blurb, the outline, that I was going to do a little coding example in C#. But as I said, I'm not trusting the internet to work and keep me connected. So I'm going to have to switch languages. I'm going to have to do it in a language that I've got installed on my laptop, obviously. Okay, I don't happen to have C# installed on this laptop. So we're going to be doing it in Ruby instead. I promise you it doesn't make any difference, because you're not here to learn a particular feature about C#. I just need a language which is a vehicle to convey the example I'm trying to convey. Okay, so we're going to be doing it in Ruby. Anyone at any time has a problem about understanding a little bit of code, as I say, just shout out. So that's how it works if you're using CyberDojo. You just select the language, your exercise, you get an ID, and anyone in the world can participate as long as they know that ID, and you click Start, and you're assigned a little animal by the server. There are 16 different animals. One of the things I learned was if I do a coding session, and I know when I'm talking about a piece of code, I say, oh, Dimitri. I'm just assuming you're called Dimitri, okay. What have you done here? This is not a good way to get feedback going, okay? Because people naturally have strong ownership of the code that they write, yeah? So if I instead say, the hippos wrote this code, it becomes I find I get much better feedback, okay? So it's a way of anonymizing who the actual players are who are playing in the dojo. So I've been assigned randomly the hippo, and this is the environment that you get to actually write the code in. And it's the world's simplest non-development environment. That's very important. Because, to state the obvious, when you are coding in a production development environment, you're trying to finish something. You're paid to finish something and it gets shipped, and hopefully it makes the company that you're part of some money, or maybe you're part of charity and it increases some goodness in some way. but you're trying to finish something. Whereas when you're doing a practice, you're not trying to finish something. There's a key difference there. So if you think you're doing a practice, just now and then maybe stop and ask yourself, why am I doing this? And if the answer comes into your head so I can finish it, you're not doing a practice. Okay? You do a practice for yourself, not for someone else. Right? You do it for yourself, and then you repeat it, and then you repeat it again, and then you repeat it again. And that seems counterintuitive. It was to me when I first started. But I've done most of these exercises here in a fair smattering of the languages, maybe a dozen times each, some of them more. And each time you do it, you think, when you start, there's no way I'm going to learn anything more. I've done it 12 times already. How can I possibly learn something more? You always learn something more, I promise you. Okay? It's amazing. So how does it work? You get the files on the left here. You can make a new file if you want. You can rename a file. And you don't get a compile button or anything like that. The only button you've got is the test button at the bottom. And when you press that test button, all the files get sent to the server, which is on my local machine in this case. The tests get run. The output is grabbed, pattern matched. And then you get a traffic light at the bottom. So a red traffic light means all the tests ran, but at least one of them failed. Okay, so if we look at the output, we can see it failed because we were expecting 54, but we got 42. So we look at the tests in Ruby, and that's why we're expecting 54, because 6 times 9 is 54. Those are Hitchhiker's Guide to the Galaxy to the fans will recognize that. And the answer is just 42. Clearly that's not going to work. So if we change it to 6 times 7 in our editor, this is really all you've got in terms of editing. Run the tests again, you get sent to the server, green traffic light at the bottom. All the tests ran and they all passed. Okay? And the other thing that can happen is you make a typo and then sent to the server, and this time it can't give you a red or a green because it couldn't even run them. And those are the only really the 3 things you can do in CyberDojo. All right? It's deliberately very, very simple. And you always get this set of files as the starting set of files. So, now we're going to do the exercise. Let's look at the instructions. Given a letter, print a diamond starting with A with the supplied letter at the widest point. For example, doing print diamond on E gives us this, where E is the widest line, and then D narrows up to the diamond, C up, B and A, and we get a diamond which, if you notice, is symmetrical about the middle axis. Okay? Another example here, print diamond C is the input, gives us C as the widest line, and again it's symmetric about the axis. So that's the one we're going to do. Okay? Not going to, again, I just chatted with a few people, and apparently Johannes did, I think it was FizzBuzz last year, or something like that. And a lot of people, who's done FizzBuzz as an exercise? Quite a few hands, less than half. So let's do this one. So test A. So immediately when I'm doing the test, I have to think about the format of the answer I'd like. So I'm going to just say, that's the answer I'd like. I'm going to have an array of strings, and the strings themselves, when I form them correctly, will give me the diamond. Okay? That should become fairly obvious. And I'll just imagine there's a function called diamond, and I pass it A. So I run that. It fails, obviously, with an amber, because I haven't got a function called diamond yet. Maybe I should rename that file. Let's do test diamond. Change it here as well. Let's rename that one to diamond. Diamond. Oops. And we'll just return A. And of course, I need to change it there as well. Sorry? I will cover that, I promise you. Where was I? Here, okay, it says wrong number of arguments, 1 for 0. That's absolutely right. So the widest character is passed in. Green. Yeah. So now I write my second test. which is B. I pass in B. And now I'm going to change this slightly so that the answer I get is B, like that. And I've deliberately put those 3 strings in their array still, over multiple lines, again, just to visually give you the clear impression that that's what I'm testing against. Okay. An important aspect of readability of maintainability in code is readability. Readability, yeah. And I was watching someone do some coding the other day, and he gave me a really good tip about just thinking concretely about readability. When I did something, he said, "What the hell are you doing there? Okay, you're forcing me to burn extra calories." That's the way he phrased it. Yeah. I thought, what a nice way of describing it. Yeah. The more calories I have to burn to try and understand the code that I'm reading, the less maintainable it is. Okay, so if I do something that's not maintainable, just, shout out. And that fails, of course, because I have still got this as my only bit of code here, right? Okay, let's stop for a minute. This technique of not even thinking about doing the correct implementation, just putting the hardwired incorrect answer, but the magic number, direct straight answer, okay, actually has a name. I mentioned it in the notes. It's called sliming. Yeah? And just to sort of retrospectively think about this for a minute, that's obviously wrong. We had one test for test A, and that was our code, and we had a green traffic light. But at that point, we know that's obviously wrong. And one of the things you can do about that when you put in a piece of slime that's obviously wrong is to say, well, okay, if it's wrong, how is it wrong, and how does that tell me what the next test is? All right? For example, in this piece of code, one of the most obvious patterns about this piece of code is I'm not looking at the input parameter. There's one input parameter, widest. I'm just not looking at it, right? So if you think about it from that perspective, that is one of the ways you could come to the realization that this could have been the way I chose my next test. I have to choose some test that forces the implementation to look at the input parameter. Otherwise, why have I got an input parameter, right? Yeah? So, it's perhaps a slightly different way of thinking about sliming. Yeah? It's a way of helping you think about what the next test might be. Okay? But we have to make it work for B, so we'll do that. And exactly as we said, we have to look at the input parameter. So if it's A, we return A. But of course, if it's B, we have to return the correct answer for B, which is, again, let's do it in the same format like we did in the test. Okay. Yeah, I think that's right. What did I do wrong? A is failing. A is failing. Let's look at it very carefully. A. I can't see it. What's going on here? I think I know. Oops. What? Thank you. Let's see if my hypothesis is right. Yeah. I was caught out by Ruby for a minute. In Ruby, an if is not really a statement. It can also be an expression, meaning it has an output value. So the end if was producing an output value, even though I should have returned the value from the previous one. Okay, so that's now passing. Okay, now I'm going to do this one more time. You might be thinking, this is crazy, what's he doing? I promise you, we are going somewhere. Because you can't carry on like this forever. Clearly you cannot carry on like this forever, okay? Now watch what I'm doing now to make this work. this test, I'm copying the middle line and I'm duplicating it, and I'm adding a new middle line. And then I have to insert a space at the beginning there and a space at the beginning there, right? It would be very easy to do that and not think about it. That's why I brought it to your attention. That's what I did. I duplicated that middle line and then added a new one in the middle. I'll come back to that. This is going to fail. We hope it does. So we'll go back to our code. And there we go, around the loop again. Widest equals C. And then copy again. Comma, put a B there. Missing one there. Good spot. And we're green. Now you'll be glad to know I'm not going to do that anymore. I have a kind of a baseball rule. You know the baseball rule? 3 strikes and you're out. Yeah? So if I've duplicated 3 times, I can't, sort of a guideline I have is that I'm not going to do it again. I'm not going to duplicate again. Okay? But I am happy to duplicate code in this seemingly crazy way up to that small amount. And again, it's something I wouldn't have done when I was a younger developer. I said, it's totally pointless, okay? But now I feel I understand software development a bit better. I see things I couldn't see before, mostly because I'm just older, okay? And that's what I wanted to show you in this particular example that we're going to lead on from now, okay? Something that certainly wasn't obvious to me, and I'm sure you're all fairly experienced developers in your own right. If I told you something that was, fairly well known, you'd have thought, well, that's great, but I knew it. So that's why I deliberately wanted to choose something that's a bit different, okay? And the first point is, when you write code like this, that is obviously slimy, the other side of that coin is, it gives you something to refactor against. Yeah, which is obvious when you say it, but I cannot tell you the number of times on my travels I visit companies and they know about test-driven development, they know about writing a failing test, and they know about making it pass, but they don't do the refactoring step. They really pay almost no or very little regard to that idea. And to be honest, the main reason that happens is because there's inappropriate time pressure being put on the developers by management, if I'm brutally honest. Okay? Time pressure is one of the most harmful things you can put onto a software development project. I promise you. Yeah? I happened to be at a conference a couple of weeks ago in America, run by one of my heroes, a guy called Jerry Weinberg. Anyone heard of Jerry Weinberg? A couple of hands. You really want to look him up. He's one of the real geniuses of software development. If you trace back the history of XP, for example, you talk to Kent Beck, as I've managed to do a couple of times, he credits Jerry Weinberg as one of the very strong influences on his development as a developer. Because Kent Beck was a junior developer at some point, wasn't he? Okay. So I strongly urge you to think about that. Jerry Weinberg, okay? And the reason I mention that is because he happened to say something at this sort of week conference. He said, suppose you have a 2-year project and your CEO says, well, my developers are good developers, we can do it in less than 2 years. And you say, the CEO says, okay, we're going to do this in a year. He said, well, now you've got a 3-year project, right? You have a 2-year project, that's how long it will actually take to do. Yeah? And you try and do it in less time, it just takes longer. I thought that was a very nice, succinct way of saying undue time pressure does way more damage than it causes more damage than anything else I see on my travels. Okay, so what about the refactoring here? Let me show you. First of all, I'm going to introduce an extra step here. You'll see why in a minute. And all I do here is return inner diamond of widest. And I change this one to inner diamond. Clearly shouldn't be any change at all there. It's still going to be green. And it is. Now, what do I do here? Remember, I'm trying to work towards an unsliming of all this slime. Yeah? And what I noticed when I first did this one was these are quite similar. That array of strings and this array of strings are really quite similar, okay? And if we could insert an extra array in a string in the middle, in that case, and in this case as well, and why not this one as well, they become really similar. Yeah, because now the implementation of C basically contains the same as the implementation of B, but just with C added in the middle. And we can imagine a recursive solution where the implementation of C works by not hardwiring the obviously wrong answer, but it calls the implementation of B, which works by calling the implementation of A. And we get a recursive solution, and all we have to do is insert the middle bit in the middle. And then remember to take away the extra line at the top. Okay? So based on that idea, we're going to progress and see what happens. So we do that, and now we have to take away that middle line. So the mid equals inner dot length divided by 2. And the lower half is going to be the array starting at 0 up to mid minus 1. That's the upper half, isn't it? So, and the lower equals the other half of the array, which is m. Mid, thank you, good Paul. Dot dot. And then in Ruby you can use -1 to say just to the end. Okay? And then what I need to do is concatenate them together. So I'm hoping that's removed the middle element. But I've done something wrong. Test diamond line 1. Ah, good spot. Thank you. Power of mob programming. Okay, so we're green. That worked. That little refactoring step worked. Okay? We've duplicated the line here and here, and then we just remove it. And that gives us the ability to work on making this the recursive implementation. Okay? So let's try it. Supposing we don't return that, we say, whoops, inner equals inner diamond of B. Right? Which is going to give us that one. That's obviously the recursive call. But again, I'm still sliming effectively because that's a hardwired value. Right? What I have to do now is again split it. So the upper equals inner 0 up to mid, so I need mid again. That lower equals inner mid plus 1 up to the end, because I'm not removing an element this time. And now I have to insert the middle element. So the middle element is going to be C plus 3 spaces. I'm obviously looking at this one here, right? Yeah. Plus C again. And I reckon after all that, I can say return upper plus 1 middle and 1 middle again, plus lower. And that should go away. Let's just comment it in case we need it for a second. Let's see. But of course, I've missed a step. Can anyone see what step I've missed? Good man. We need extra spaces. So we have to go in. Well, I can do it in one line. Let's try and be brave. We have to map the string so that I get a space at the beginning of the string. Let's try that. There we are, green. So now we can get rid of the comment. Should still be green. We can do a little bit of refactoring here because widest is C, look. So I can take that one there as widest. And again as widest. That should still work. It does. What about these three spaces? Spaces equals space times 3. That should still work. How did I get the 3? Why is n 3? Well, I'm not going to worry about that for a minute. I'm going to take a next step, okay? Because I'm going to, again, deliberately introduce duplication. Yeah? I'm going to copy all that, put it there. And again, I'm just going to comment this one out for a minute. But this one's inner diamond of A, because this is the B case we're doing. We take the halfway, we take the two halves again. We need one space this time, right? Excuse me. I think 1. Let's look at our tests. That can tell us, can't I? 1 space, right? Yeah, 1 space for the middle when it's like that. 3 spaces for the middle when it goes up in 2s. Okay? So it's a surprisingly tricky little problem, this one. If you've never done the print diamond kata, I really urge you to try it. It's really, you think, oh, it's easy. It's really difficult. There's lots and lots of ways to do it. This is just the recursive way, okay? So anyway, we can always, the acid test is whether everything's green, and it is, okay? So now we can get rid of that commented out code, right? And you should notice that these are very similar. We're deliberately working towards, as I said, completely identical duplicated code, because then we'll be able to collapse it. So let's look carefully and see what's not duplicated. That's the first thing. Inner diamond of the previous character from the widest. At the moment we're just hardwiring that. Yeah. So again, we write the code we want to write. Previous of the widest, like that, which means we need a function called previous, widest, and that needs to be widest dot ord -1 char. See if that works. It does. So we can replace the other one. So that should work previous of widest 2. It does, good. And now we look at this one, and I think that's the last thing that's left. Okay, so let's figure this one out. This is going to be widest.ord minus a.ord times 2 minus 1, I reckon. Try one of them. And it is, which means we can try it. We'll copy it down here. And it is. And now, the bit we've been working towards, we just delete that and all of that. And it should work. Doesn't it feel good when you delete code like that, yeah? Doesn't it feel good when you delete code? Need to indent that. Just a little refactoring. And now, of course, we might want to change this slightly. I think this deserves an else, actually. So let's put that back in like that. Just check we haven't broken anything still. And it's worth looking at this because when you've been hardwiring the values and you collapse like that, very often you'll be left with pieces of code that have names that are not particularly appropriate. Okay? I think we're not too bad in this case. Middle works in whatever it is, so that's fine, upper and lower. But we should always look for opportunities to refactor. For example, this. I don't like this. Let's spaces of widest is what we want. So let's have another little function called spaces of widest. Copy that. So n is the widest, and then we simply return space times n. That can go away, that can go away. And there's a few other bits and bobs we could do to tidy that up a bit. I'm not going to bother right now. Because now, if it was me, what I would do is this. I'd take that test, copy it again. This is the one for D. Duplicate the C. Put another one inside. Oops. Put the D in after adding a space everywhere else. D to there. And this is the moment when you actually find out whether you've done it right or not. Yes. Yeah. So I don't know whether any of you have seen that technique before. Okay. Just to remind, let's just recap slightly. You deliberately introduce duplication. Well, first of all, you slime. You just put the hardwired answers in. Yeah. Enough times so that you can refactor from that. And then you work towards making the implementations absolutely identical, but they are duplicated. All right? And then you should be able to collapse away. Now, once you realize that, certainly when I realized that cycle was a possibility, I found it quite a freeing moment, because the sort of the wheel works both ways. Knowing that gives you permission almost to do more slimy code. You can write code that you, again, like I said, when I was much, much younger, I wouldn't have dreamed of writing code like that. But now I recognize that it's how you getting to the end is the important thing, and how you get there is a vital aspect of that. Okay? Is that all clear as mud? Any questions about that? Yeah? That's an excellent question. Why do we write tests? Why do you write tests? To guide the design? Any other answers? There's no right answer. So that we can run them in a regression suite fashion? Absolutely. Yeah. Thinking about requirements. Now I'm just going to stop you on that one. Terrible pen. Oops. To make sure my application works. Now, it would be nice if we could write tests that did indeed make sure that the application works, but unfortunately, we can't do that. And again, this was a trap I fell into pretty often when I was younger, the idea that you can prove by all these tests that you've written that your code always works, because there's sort of a hidden always in there, isn't there? Okay, just bending it slightly. You can't do that. It's just not possible for anything but the most trivial problems. Okay. So, knowing that we can't prove what we're building is working based on the tests, again, we get the other answers that we got to the answer to the question I asked, why do we write our tests? To guide the design, to get more confidence, basically. Yeah, to manage risk. Yeah. So, in this case, should you write more tests for things like Z? There is no right or wrong answer. It's about what you feel in your gut here, based on this idea of how likely do you think an extra test is going to find a bug? Right? That's really, I think, the most honest answer. And again, I wouldn't have done that when I was younger. I'd have gone, on and on, writing more tests, doing the Z case maybe. But now I'm older, I think, do I really want to do that? Okay? Because I'm getting sufficiently old that I look back and I think, okay, 47 years backwards, 47 years forwards, that makes me 94. I'm going to use my time more wisely from now on, okay? Time is one of the most valuable things. So in this case, I wouldn't write a test for Z for that reason, okay? But I would write tests for other cases where I thought I was addressing the risk better, okay? But that's the most honest answer I can give you. Yeah. Great question, though. And it leads into, because I'd made a note of the things I promised I'd talk about at the front here. Always start with the red, we'll come to that. Oh, good. Excellent. Code and tests. Yes, I promised I'd talk about the difference between code and tests. So here's some code in whatever language you like, and here's some tests in whatever language you like. Yeah. And this is still code, obviously. Right? It's just that this is the tests that test this code, and this is what we're actually shipping. Although I have, in my travels, come across a few companies that ship both of these. There's some merit to that idea, because if you've got this live in the field, maybe there's a switch that you can throw, secret switch that you can throw, which reruns the tests live on the customer's machine. That's quite a useful thing, okay? But ignoring that, this is what you actually ship, okay? Now, imagine, well, let's not imagine, let's use an actual example. Who's heard of this Mccabe cyclomatic complexity? Yeah, quite a few hands. Very simple metric. You run a function, you don't run a function, you give the function to this Mccabe tool, and it tells you the number of paths through that function. Okay, so if you've got a function that's got one if, yeah, obviously the if can be true or it can be false, so that's two paths. Right? And that's just a measure of the complexity. And it's an absolute known correlation that the higher that number, the more likely there will be bugs in that function. Okay? Which, if you think about it, is totally not surprising. Because the bigger the number is, the more complicated it is. And the harder it is to get it in your brain correctly. Right? And that's where the bugs live. Right? So we're aiming for low numbers. But anyway, now you know what it is. Let's imagine we ran that little metric through all of our functions, okay, and the average Mccabe cyclomatic complexity for all our functions came out, let's be generous, at 4.6 with some variance, all right? And then we did the same thing for the tests, because the tests are still code, obviously. Each of the functions is a function. Get the cyclomatic complexity for them, and we run that, and we get an average of 4.9 with some variance, okay? Can anyone see the problem? Excellent. Okay? You've given me the answer when all I asked was what the problem is, right? Which tells me, if nothing else, you're an engineer, right? Okay? But hopefully you can see that this is clearly not going to work. How do you know there aren't bugs in the tests? You've got less confidence that there's bugs in the test than you do. What you can't do in this case is make more tests over here that test the tests, right? And have a complexity of 5.1. This doesn't work, obviously, right? You're going nowhere if you take that route. So what do we aim for as a complexity here? 1. Okay? This is a really, really key, important difference between code and test code. It's all code, but it's not the same. You should not think about the way you develop code or let your gut feel the code in the same way when you're writing code as when you're writing tests. They are not the same thing. They respond to different forces. Okay? Now, what does this mean? It really means you're not comparing like with like. It's not even comparing apples and oranges, really. It's more like comparing apples and frogs. If you take the number of lines of code here and the number of lines of code here, you're going to get way more lines of code in your test code in a healthy environment than you get lines of code in the actual code itself. The test code is just bound to have more lines of code. That's the price you pay for having complexity of 1. Okay? There's just more of them. This one tests this particular path. Yeah? This one particular path